Okay, let's begin. Hi, everyone. Thank you all for coming. I'm happy and excited to see so many people here. Also, it's my first year here at Jfokus, so I'm like double excited for it. And in this session, we'll talk about some of the possibilities to optimize your application performance and how you can use GraalVM to achieve that. So the very idea of GraalVM is quite connected to the performance topic because it was designed from the ground up to be this virtual machine providing high performance for different applications. So the whole idea is to run applications faster anywhere. The way we plan on achieving it is through a couple of things. So first of all, GraalVM offers you this opportunity to have high performance for abstractions of any language. Why this is important is because sometimes performance can be considered a trade-off comparing to abstractions, meaning writing good code, right? Sometimes people would think that they would need to, optimize manually a lot to get high performance. Well, we think that that should not necessarily be the case, and you should leave this kind of optimizations to your underlying system, VM in our case. The second goal we have to make this mission happen is to offer this new execution mode of Java applications. So if you AOT compile them into native binaries, this way you have fast startup and low memory footprint, and we'll be talking about this mode quite a bit today. One more thing is convenient language interop. So since there are multiple languages implemented on GraalVM as one platform, they can interact together nicely and fast, and this is something you can get out of the box without additional work from your side. And the last one is that GraalVM can easily be embedded in various environments, such as databases, so you can get access to the languages and features that it offers in those environments. So if you have heard something about GraalVM, you may have seen this high-level ecosystem overview. I will go through it very briefly. So on top here, there are languages that GraalVM supports, and below are the platforms where you can use GraalVM. So in terms of languages, GraalVM can run your normal unmodified Java apps that would be in the context of OpenJDK here below. Also, it has a JavaScript engine so that you can execute JavaScript code as well as Ruby code. And if you're interested in things like statistics and data processing, data visualization, you may look into R or Python for that. And we also have a runtime to run LLVM languages on top of GraalVM. So for the platforms, you can run Node.js applications with GraalVM. You can use it, as I mentioned, in a database, and for example, use some, NPM module to verify data in your database. And the last one here, standalone, that's the native image mode that I mentioned when your applications runs standalone without depending on the JVM to run. So a fun fact about these languages, recently we asked this question on Twitter, which of these languages that GraalVM supports is the most exciting for you or interesting for you? What do you think? What was the answer? Come on, just shout out. Yeah, we thought that Java might be leading the list, and also Twitter has very limited list of options you can ask in one voting, so we excluded Java from that. Yeah, just, have fair competition, and the results were like this. I personally was surprised a bit. I was betting on JavaScript, but in this contest, at least in our Twitter community, Python won. Yeah, just a fun fact and nice feedback from our community that Python on GraalVM is kind of interesting for people, and we should look more into it. Yeah, production ready. So this is a nice update from May last year, because the exact organization where I work, it's called Oracle Labs. So we are this R&D unit at Oracle, and we do a lot of scientific research. And we, as GraalVM team, are super happy that now it's also production ready, and you can use it safely in production. It comes in two editions. One is called the Community Edition, the other one is Enterprise Edition. So the Community Edition is open source and available on GitHub. You can use it in your production environment. Enterprise Edition is free for evaluation purposes, free for development, but it would require a license to run in production. Yeah, and you can get both from this website, graalvm.org. That's the main entry point for all things GraalVM related. Talking about the open source version, I just wanted to quickly show how many repositories we have. So since we have so many features and capabilities, this is an overview. We have all those language implementations in orange. We have a core repository that has the compiler, language implementation API, all of that, and also we have tools represented by GraalVM. So moving on to performance and kind of how you can optimize for it with GraalVM. So when you talk about performance, how do you measure it? Like, what are the metrics that you look at? Come on. That's actually not a very common response, but I like it. Yeah, so you said startup time and memory. What else? Latency, yeah. I'm actually surprised I haven't heard throughput yet. Maybe it's like, too obvious for you to name it. But anyway, I borrowed this list from this book, Optimizing Java. If you want to look more into these definitions that I will show right now, you can dig into it. But yeah, the most common things people look mostly at are throughput and latency. You can also look at capacity, meaning like how many operations can handle your system or subsystem simultaneously. Or you can look at utilization, meaning does your system really efficiently utilize the resources it has, or is your CPU busy doing some invaluable work while your application is underutilizing it. One more thing you can look at efficiency. So, for example, if at some point in time you would require twice as much resources to do the same job, that perhaps would be the sign for you that you are less efficient, and you might look into those issues and how to deal with them. And scalability, meaning that, for example, if you add, I don't know, twice as much, 3 times as much resources, would you have this like perfect linear scaling, or would you encounter some issues with it? And the last one here is degradation, meaning if the additional load on your system occurs, how would it handle it, and what would be the outcome of it? Yeah, so talking about how GraalVM can help you there. So if you are a Java developer and we are at Jfokus, so I assume most of you in this room are, the number one starting point for you if you're considering to run your Java application on GraalVM would be this slide. So GraalVM for Java can offer these 2 execution modes. It can run your application in just-in-time compilation mode, meaning dynamic execution, or it can run in the AOT mode on the right, which is as a native image. And this is kind of an important slide because many people are excited about native image, the AOT mode, and they get confused that that's the only thing GraalVM can offer. But now you can do both with GraalVM, and you can choose between those 2 modes depending on what your goals and what your performance criteria are. So talking a bit more detail about GraalVM native image. So it's a Java program compiled ahead of time into a standalone native executable. The reason to do so would be that you will get fast startup and low memory footprint because it no longer needs JVM to run. So it can start faster. It needs only just a fraction of memory comparing to running on a JVM. And it's ahead of time compiled using the same GraalVM compiler. So to compare those 2, JIT mode and AOT mode, this is an overview of how the JVM dynamically executes your code. I'm sure you're familiar with this, so I will just emphasize 2 concepts here. So the first one is dynamic compilation, meaning that as your application is running, the JVM collects information about it and optimizes your code on the go depending on the information that it has. And it allows for very specific optimizations specific to your application and what it does. So that's how JVM achieves this famous high peak performance. And the second one important here is de-optimization, meaning that it can perform very aggressive optimizations, because if something goes wrong, like for example, we've optimized for specific type of objects and then we see different objects in that place, we can de-optimize and go back because we have this opportunity. So we are flexible and adaptive and we can always go back. So with native image, things are slightly different. So you can think of it as of working with your application into 2 steps. That would be image build time and image runtime. And the idea here is to move all the heavy lifting from the runtime to build time. So what happens at the image build time? we start analyzing your application starting from its main entry point, and we are looking for all the code that is reachable in there. And also, we perform what we call heap snapshotting. So we are running initializations, and we create this image heap that your application will be able to start with. And we perform all of this until we see that all the code that we could find is reached, and we are ready to prepare this binary. So the idea is that you move all of that work to the image build time, so that next, every single time you start your application, it doesn't have to do all of that, and this is the way it can start faster. So talking about startup performance, as you see in those two pictures, like how JIT and AOT compare in terms of startup. So in JIT mode, you do a lot of all this work at the very beginning, right? So you need to load your code, you need to verify it, you need to profile it, you start interpreting, you start compiling, and then when you've done all of that, you run with optimized machine code. In AOT mode, things are different. So we load the executable itself, and then we start with this optimized code that we optimized at the image build time. So that's how they are different in terms of startup time. Once again, in terms of memory footprint, situation is also similar, because you would need to load the JVM executable. You need to keep all those data around while the application is running, because you need this infrastructure to optimize and compile your code. In AOT mode, you just need your executable itself and this application data. So if you look at this performance metrics that are related to a compilation and something that compilation can affect, there are multiple things you can optimize for, and this is a bit of a trade-off, like you would need to choose what are your goals depending on your application. So JIT, this is something we know and love it for, right? It's very good for peak throughput, because you can optimize based on that real-time information, and you can really optimize for reducing max latency. AOT, on the other side, is on this other side of things. So since you don't have to do that much work at the beginning, you can optimize for startup time and for memory usage. But since it doesn't have all that tools and possibilities of JIT, it would lag a bit in terms of throughput and latency, but afterwards we will talk a bit about how we can handle that. Yeah, let's try a demo. What's going on? Okay. Okay, it was crashing right before the session, but I really want to show it to you, so I'm hoping it will be fine. Guys in the back, can you see it? Yeah, good. So I have this Micronaut application, which is a simple, basic web service that would reply to my request with a random conference name. So I'm using GraalVM, and I will be using it in both modes. So the first time I would run it in a just-in-time compilation mode. Okay, we are up. That's already very good. I will show you what it does. Yeah, so that's basically it, returning me some random name. Let me now kill it. And also, I have it already compiled as this native image I've been talking about. So it's over here. So it's a binary. And if I run it, yeah, so the numbers, yeah, let me see that it's doing the same thing. Yeah. So the numbers, the first time the startup time was 1.2. And I must say it was warmed up a bit because I tried it once again before the session. I think the very first time it was about 2 seconds. And in AOT mode, it's 16 milliseconds. So that's to start it. But what if you wanted to know more about it? So for example, how much time and resources it needs to successfully serve the first request. So let me do this. For that, I will use a script that will measure startup time and CPU usage. Looks good. Yeah, So this is the time the startup was completed, and also the CPU time used was like this. That's for JIT mode. For AOT mode, yeah, once again, it doesn't need that much CPU because it only basically serves this one request, and all the like overhead work was done when we were actually building the image. Yeah, and let me do the last tricky part for this application. Yeah, looks good. Yeah, so I'm using a tool called PS Record that will observe my process, and it will output for me data about CPU usage and also memory usage for my application. Let me find it. Uh, 1417 should be it. Yeah, so that's how my application was behaving in JIT mode. What we see here, so in red, that's the CPU usage, and in blue, that's memory usage. So you see that up until 2 seconds, the system is quite busy because we are doing all that we talked about, like loading code, verifying, profiling, optimizing, and so on. And those smaller spikes over there, that's actually serving these few requests. Let me rename it so it's not deleted and run it second time in AOT mode. Yeah, we see another image appeared. Let me open them side by side so we can compare. So on the left, that's JIT mode, and on the right, that's AOT mode. So the scale, if you look at here, is different. So you must understand that it's also, zoomed in a bit on the right. But the bottom line is that in the second case, it only, has these minor spikes when we actually receive those requests. And we don't need also that much memory because that's a compiled native binary. Yeah, so that was about startup time and memory usage. So I showed you a Micronaut example, but in fact, there are many frameworks working with GraalVM. You can choose whatever you like, and there is Spring Boot missing on this slide, but it will be later on another one. So if you look at them, that's comparing startup time for GraalVM native image, which is here on top, this green one, and also JDK 12 and JDK 8 startup time for the same application. So basically, the bottom line here is not comparing frameworks to each other, but rather comparing what you can achieve depending on the mode that you choose. The same goes for memory. So no matter which framework you are looking at, you can get this significant memory reduction if you're going with AOT mode. So specifically for microservices, this is something you might be interested in if you want something to start fast and be done fast and don't need that much memory. So peak performance. So just to recap that image comparing performance metrics for JIT and AOT, you remember that JIT is here, so it's really good for peak throughput. And AOT needs to find its own way to optimize for peak throughput because of that information not being available. So what we have here, if you compare those two side by side, profiling and all the runtime information is what allows us to have this peak throughput in JIT mode, and also the way we can optimize aggressively and go back if that's no longer valid. So for AOT, things are trickier because that's image build time, and it's done under closed world assumption, meaning we don't have that information yet. But what we can do there, first of all, when we build the image, we kind of optimize for all the cases because we don't have a way to know which one would be the most necessary. So that's one thing that we do. Second is that if you want predictable performance, and that's something sometimes you actually need, that you know that you will start at some point with already good performance and it will keep stable. So you may consider it in terms of performance, like peak throughput. And also there is one more interesting thing, profile-guided optimizations here that can help you in this case. So what I mean by that, if you could collect profiling information about your application and give it to us when we actually build the native image, we can use this information to optimize for those cases that you provided us information about. And this way we can build image aware of this profiling information and this way providing better performance. So the way it compares to a JIT system, you see that this dark green one that is like Java Hotspot VM, meaning JIT system, and the yellow and red ones, that's GraalVM. So having those profile-guided optimizations allow us to be on par with a JIT system, even in terms of peak performance. You see that it's like still a bit below, but having that you get startup time and memory footprint improved, this might be like a trade-off you would be considering. Yeah, so this is like the situation is right now, and we are, sorry, I did not see that happening. Yeah, and also we are working to making sure that native image can provide you all of that. So there are a couple of things we are working about, and we expect them to be public in a few months, so that you can optimize for various performance optimizations, specifically with GraalVM. Yeah, so what if you wanted to start to compile your Java application as a native image? Where do you start and what do you do about it? So there is this nice article from our native image team lead, Christian Wimmer, about how you can simplify configuration of native image. Because some things with native image would require additional configuration from you. So if you want to use things like reflection and GNI and all of that, you would need to provide this configuration file for us. But we also have an agent that can output this configuration for you, so you can give it to us. One more thing about native image is that perhaps an easy way to go for it is through one of those frameworks. So I've shown you Micronaut example, and it's working really nicely. This is something you can build yourself if you go to their website and check it. One more framework that is working with it is Helidon, and also there are Helidon people out there at this conference, so you can talk to them if you have more questions. You might have heard about Jfokus, offering this nice, fast startup and less memory consumption for your application. So that's something you can also try, and that allows you to compile application as a GraalVM native image. And recently, we had this new update from Spring Boot team. So they have this very interesting project called Spring Graal Native, where you can get it and build some of the Spring Boot applications as GraalVM native images. That is something I've been asked a few times at this conference. So if you are interested in that, just go for that link. You can get it, and you can build it and see how it behaves. I wanted also to show you this Spring Boot example. I do hope, once again, that it works. So I already have it compiled as a native image over here. Oh my God, what's happening? I'm so sorry, like my laptop is not compatible with infrastructure here. It's still not on. Can we do something about it? I'm so sorry. Maybe we can do minor Q&A while we are waiting for it to be fixed. Yeah? Hi. I do hear you.
Just check up on PGO.
Yeah. That's correct, yeah.
Is there any ongoing plans for C availability? Can you repeat the question?
Yeah, I can repeat for you. So the question was about those profile guide optimizations that I show that allow you to get even better peak performance with a native image, like whether or not there are plans to incorporate it into Community Edition too, right? That's not something that I can answer publicly, perhaps. Like this long-running project roadmap, unfortunately, like if I could, I would answer it. I do have some updates coming up soon that I can share with you, but honestly, this is not something I can answer for sure publicly, so sorry, my bad. Are we good? Yeah. This was like this dramatic pause to show you Spring Boot app starting as GraalVM native image. Yeah, it looks like it's up. Let me look at it. Yeah, so that's a pet clinic app. Let me just zoom out because it looks weird. Yeah, so yeah, basic pet clinic application where you can, look for owners, look at the doctor's list, and so on. And the interesting part about it, so this is the startup time of our application. You see that's 0.6 seconds. Looking good? Yeah, and I must warn you also that this is still a work in progress. So I think they promised that they have this roadmap for GraalVM native image support, and they will be delivering more updates regarding GraalVM native image this year. So I think there is still possibility to optimize it even more, but that's something that's already looking interesting. So you can also look at it in this GitHub page. Yeah, so just to summarize those two modes, yeah, like JIT and AOT, that's a good way to use GraalVM native image if you are looking at things like startup time and memory footprint. So specifically, if you're interested in things like microservices and cloud environments, that might be like a better way for you to go with. If you are looking for very good, like long-running peak performance, that perhaps GraalVM JIT can be a better way for you, having all of that information available. So that's like a quick summary of when you can and should use each of those. I want to briefly also touch about the other languages available in GraalVM ecosystem. So the benefit of having languages implemented of GraalVM is that you get this whole ecosystem available, and this is the way all these languages are fairly easy implemented. This is something you can do also for yourself. Just get a language implemented on top of GraalVM, and you get access to this ecosystem of tools for you. One of the languages I wanted to mention is JavaScript. So we have our own JavaScript engine. We constantly test it to make sure it's compatible to the latest standards, and there are some interesting cases of companies running it in production. I will mention it in a bit. We have this compatibility tool, so if you are interested in some specific, like NPM module or something from Python or Ruby, you can check whether or not it's compatible with what you are looking for. We have Nethorn migration guide because we have this question from time to time, like I used to use Nethorn, what do I do about it now, how do I migrate? So that's an easy way to migrate. You can do all kind of fantastic applications with GraalVM. So this application over here, that's, you see there is JavaScript over here, but also it's using Java and it's using R. So all those three languages are working together to output this application. And I hope it doesn't do that thing again. Yeah. I wanted to show you one more example of a polyglot application. So it wouldn't be as crazy as that one, but would be more practical in a way. So I have this Java application that also has some of the JavaScript over here. So I can, like, this is a Java application, and I'm using GraalVM as my default distribution. I can just run it like this. So hello from Java, and hello from JavaScript. But also, since it's a Java application, I can compile it to a native image and still have JavaScript in that application. So I already did it, and if I run it, you see that it's working faster, and there is still this JavaScript present being executed. So moving on. Yeah, and that's the example I mentioned about database, how you can use, for example, this npm module in your database where you can validate things. So for example, if you're looking at this first row, it looks kind of like an email, like it has a proper syntax, but if you look at the second one, it does not. And even more fantastic stuff. So this is something we've been working on with the Gluon team. So you can write your application in Java and run it on all those devices, like, for example, iOS devices, things like iPhones and iPads and so on. And if you have this cool demo of a basic like chat application written in Java running on iOS. So this is perhaps not the most common case where you would use your Java knowledge, but definitely something interesting to look into. Yeah, and also if you're looking at R, so things like statistics and data science, you can use our implementation. It's called FastR. And the same goes for Python, so that's a Python 3 implementation. I just want to warn you that if you want to use Python, this is like the youngest language in our language ecosystem, so it's not quite there yet that you can just take any random Python app and run it. But some things, some Python apps you can still run with GraalVM. Once again, something you can look into. And we have this collaboration with NVIDIA where you can use GPUs from your GraalVM applications. Yeah, I wanted to switch now really quickly to a few companies that are using GraalVM in production and how exactly they are using it. So you might know this guy. I think everyone knows him. That's Chris Tellinger from Twitter. He will be, if I'm not mistaken, also doing a keynote here later today. So Twitter is one of the first early adopters of GraalVM, and they're using it in production on their Scala microservices for something like 2.5 years now, and reporting good results in terms of peak performance and reducing latency. One more interesting case, I like it very much, so that's Dutch National Police. You can find this talk online. So they had this interesting project, if I remember correctly, like digitalizing their paperwork, moving all of that into digital environment, and also they wanted to do some of data science on those docs. So I think they have the whole thing written in Scala, but they are using R specifically for its data science capabilities. Oracle Cloud Infrastructure itself also uses GraalVM in production, so for things like better peak performance and reducing GC times, this is something they get from GraalVM. Yeah, I also mentioned NVIDIA already. Yeah, this is one, I think, the most recent one, at least like public story. So there is this social network called Odnoklassniki. I'm not sure if somebody in the room knows it. Knows it? Okay, a few people. Yeah, so they're this huge social, I don't know, like platform, and they're using GraalVM together with their Java application. So GraalVM there is handling React server-side rendering. Very interesting case. There is a blog post about it, and I think they promised that I will write one more, so I myself really look forward to it. Regarding project roadmap, so if you, for example, considered GraalVM or you already moved to it and you would like to know what's the schedule of updates for it, so there is this information available so you know when you kind of can or have to prepare for an update. And some of the recent updates, so our community was voting actively for JDK 11-based builds, so now they are available, and also some other things like WebAssembly support and some new language features and native image features are also available. What we are looking for updating, extending our platform support right now. We are also looking into having new GC in native image. Once again, it should contribute to having better performance. And also, we are actively working with communities, so if there is something you would like to see, you can talk to us and give us an idea or contribute. We will be happy to see it happening. Yeah, that's about the ways to contribute. So there are multiple ways. Can be like the actual PR or can be contribution to docs. All of that is welcome. Just to summarize, so what are the best cases for you to consider GraalVM? So first of all, if you want to have high performance, no matter which language you are using, GraalVM can be a good fit for you in this case. Also, if you want to have this fast startup, low memory footprint for your Java application, you can consider the GraalVM AOT mode. One more is convenient language interop. So language interop where you can use different things from different languages and they will be still working fast. And the last one is simple embeddability in various environments where once again you can benefit from the language and features that it has. If you are curious about it, there are a couple of ways how you can proceed. You can download and actually try it. We are very active on Twitter, so that's the best source to follow our updates. And if you need help, we have this community Slack where you can talk to us and to the community, and we will help you with it. Also, you can drop us an email on this mailing list once again to get help. That's all I had. That's my name, that's my Twitter. If you have any question, you can just talk to me, and I think we still have time for questions right now.
Any more questions?
Super cool, like one question. I don't think that ever happened to me.
Since I've most used GraalVM in the JIT mode for low latency purposes, I'm concerned about the lack of support, so to say, with the new experimental GCs like Shenandoah and ZGZ. What can you say about that?
Yeah, I'm no GC expert, but the way I understand it is since we are using an external compiler, there are some limitations to, like, maybe not limitations, but some extra effort needed to make it work with more GCs. So that's something definitely we should be looking at into our roadmap, but that's the reason, yeah, so since we are using external compiler, that's not trivial. But you mentioned you're already using it?
Latency.
Okay, but you're already using it, so not just asking.
I have used it, yes.
Okay, I need to talk to you afterwards, okay. More questions? I can barely see because of the lights, but I think no. Okay.
Hello. Is it possible
Hi.
to explain fastly how the JIT mode is better than normal, usual JRE or like normal Oracle VM?
Yeah, if I understood you correctly, you are asking like how JIT is better than your like normal Oracle distribution. Yeah, so yeah, maybe that wasn't like super clear. Yeah, what we bring kind of new to the Java ecosystem is the AOT mode. So the mode where you get those native executables in the end. In terms of JIT, if you would compare GraalVM to other distributions, like we have all the benefits that JIT has comparing and trade-offs comparing to AOT, but what is different is the compiler. So if you are using the hotspot VM, you, like default one, you have C2 as your top tier compiler, and in our case, your top tier compiler is replaced with GraalVM compiler. That is slightly different, but in general, it's more of a question like whether you need to choose JIT versus AOT. So that would be the real question. But like comparing to default hotspot VM, the compiler would be different. And you may run it on your workload and see how it compares because it has some new optimizations, so it might give you even better performance. Yeah, I guess that's it. I'm here for the whole day. And also, I got some GraalVM stickers here. So yeah, come talk to me, and thank you for coming.
Thank you.